And now for something really exciting. Actually, just kidding, this one's kind of redundant. But it's got a lot of important stuff, so we'll go through it. Now what they want us to do is find the trigonometric ratios for every angle that has the same reference angle as 60 degrees. Yeah, that's going to be a little tedious because we've got 60 degrees, and then we're going to have, if we flip it, whatever this point is, if we flip it into this quadrant, this will be 60 degrees. And then if we flip it into the next quadrant and make this 60 degrees, there's another one, and we have to do it one more time. And that becomes 60 degrees. So, yeah, now we've got 4 different angles that all have a reference angle of 60 degrees, and we don't know what the point is. What's the point? Anyway, so we can start by trying to figure out the sides of a triangle that would work for us. And you might remember from 6.1 that in number 5 we dealt with a triangle that was, well, a lot like this one. We had 60 degrees here, we made this 2, we made this 1, and we made this root 3. What your book wants you to do for this one is to decide that this is 1. We're just going to use a radius of 1. So it sounds really simple, but it kind of sucks because we already know what it would be for 2. What we can do though, because they're going to be similar triangles, is just cut all those values in half. So if this equals 1 and that one was 2, then this side will be half of what it was there. So this one will be root 3 over 2. And this one down here, I'm just going to get rid of this, will be 0.5, or I guess we could agree with your textbook and write it 1 over 2. So now we have the sides. That one's in quadrant 1. Everything's positive in quadrant 1. X is positive, Y is positive in quadrant 1. So we could start with making a table where we have theta, and we'll call this one 60 degrees because we're just dealing with it in that quadrant. Now, point P on the terminal arm there is 1/2 and root 3 over 2 because that's by definition what my X and Y points are. So then I can use cos, which is X over R. So to get that, I'm just going to go X over R. Here's where the 1 comes in handy, because now anytime we're over R, it's just going to be over 1, so it simplifies to whatever X is. So cos is 1/2. You could write it 1/2 over 1. Or you could just write it as 1/2 because 1/2 divided by 1 is just 1/2. See, that's why they made it 1. Now the next one is sine, which is y over r. Again, r is 1. This is beautiful. So instead of having root 3 over 2 over 1, we can just write root 3 over 2. Tan is our last one, and tan is y over x. So, because it's opposite over adjacent, that's kind of a weird one. I'm going to write it a little different because y over x means y divided by x. So rather than stack a fraction, which is just looks painful, like look at this, y over x. Ouch, ow, ow, make it stop. So what you do instead is you go root 3 over 2 divided by 1/2. And if you remember, this is a bit of a stretch, but in grade 8 we did learn that if you were dividing a fraction by a fraction that had the same denominator, then you could just cancel out the denominators. And you could go root 3 over 1, which is just root 3. Now, if you don't remember that, we could do it the long way. We could go root 3 times 2 over 1, because when you're dividing fractions, you multiply the reciprocal. And therefore, 2 and 2 cancel out, and you're still left with 3 over 1, which equals, or root 3 over 1, which equals root 3. So, yeah, it's easier to write it this way and work your way through it than to try to stack fractions. Okay, that starts us off. We've got our first line set. We know what we're doing now. The only tricky part is moving forward, we have to identify the new angle and the new points. So for our second angle, we're done with this one now. We're going to go here. Now the reference angle is 60 degrees, but in this quadrant, we're going to go 180 minus the reference angle, which would give us 120 degrees. So this is 120 degrees. We'll write that down here. The other thing we need to be aware of is that our x just became negative. We're in quadrant 2 where x is negative. So our points here are going to be negative a half and root 3 over 2. Now when we go through here, we're going to have to remember that. Because r is 1, we just get rid of it. So all we have to do now is put cos is negative 1/2 because it's x. Sine is root 3 over 2. And tan is root 3 over 2 divided by negative 1/2, which is going to give us negative root 3. That was easier, right? We've got our setup established. We're just kind of through the steps now. Speaking of steps, now we got to deal with the next quadrant. So I'm going to make a pretty little line that way. And that's what we deal with now. So we're in quadrant 3 where both of them are negative. I've got negative x and negative y. So my point is going to be negative 1/2 negative root 3 over 2, and my angle is going to be 180 degrees plus the reference angle, which is going to give me 240 degrees. So I write my 240 degrees here. I write my point here, negative 1/2 negative root 3 over 2. And again, these are just my x and y values. And this one is negative root 3 over 2 divided by negative 1/2, which is going to give me a positive, root 3. What we're doing as we go through this is just establishing the pattern, figuring out which quadrants have negatives in x or y or both, and then how that translates into tan. Because tan's a calculation. You can't just look at x or y. You have to look at y over x. So as you can see, in quadrant 1, tan is positive. In quadrant 2, tan is negative because one, x or y, is negative and the other isn't. Quadrant 3, they're both negative, which makes tan positive. So it's a pattern. Let's see what happens in the next one. So here, we've got our 60 degrees here, and we're going to all the way over to here. And we've already established that it's 360 degrees minus 60, which gives me 300 degrees this time. Right? Because he's just 60 degrees short of the finish line of making a full circle. And x is positive because it's on that side, but y is negative because it's still below. So I'm going to have 1/2 here, but negative, slow down, negative root 3 over 2. 1/2 negative root 3 over 2. Does it matter where I put the negative? Not really, as long as there's one of them. Okay, again, this is just my x, this is just my y, and this one is the same except for the sign. So I have a negative here divided by a positive, which gives me a negative root 3. So we know that tan is negative in quadrant 4. This is going to stay no matter what angle you had. It didn't matter what angle we chose. The patterns hold true. So we can see where sine is negative, where cos is negative, and where tan is negative. Now cosine is R is never going to have a positive or a negative, so it's just always just assume positive. So what we have here is that cos is positive in quadrant 1 and quadrant 4 because x is. Cos is negative in quadrant 2 and quadrant 3 because x is. Sine, same thing can be said. Sine is going to be positive in quadrant 1 and quadrant 2 because y is. And it's going to be negative in 3 and 4 because y is. It's below the horizon. Tan's a little trickier because it depends on what a cos and sine are. But tan's going to be positive where they're both positive and positive where they're both negative. It's going to be negative where one is positive and the other is negative. So tan goes positive, negative, positive, negative. And that's always going to hold true no matter what the angle is that you're dealing with. There's this relationship between positive and negative and what quadrant you're in. And that's really what this exercise is trying to show you.